every silo is owned by someone, and it's done very well. It's set up very well per silo, but agentic AI only produces enough return on investment when we start to retrieve information from a lot of silos. Otherwise, it doesn't produce an added value that much, and that's really where we currently stand. So it's a nice Gemini-generated picture, as I think in the meantime everybody sees. They always look like this, no? But it's nice. You have this prototype plateau, barriers to entry. There's also maintenance in all kind of RAG systems. You always see a lot of code. The subject matter experts cannot be involved, interestingly, so it's done by the engineers now. That's, for me, a big problem. So just recently we went to a bank, and then the economist said, I cannot subscribe to these RAG systems. I get every second week our data scientists come to me and show me the best next result. But they always have problems, hallucination. And then when I ask them, how can I, being accountable for the results, how can I can get involved? They tell me, submit the Jira ticket. I'm not in, yeah. So you really need a way to let the subject matter expert, the business guys, to be better involved in this setup. And I'm not seeing that. I saw a lot of demos of lots of code. If I'm the SME, I'm lost. I'm not in. I don't like AI as a subject matter expert. But at the end of the day, I'm accountable. I have to sign it up. And this is the current situation. And so what we believe, and now have seen in many, many cases already, is you need a semantic layer, at least. So I will come also to the point, what's the difference between a semantic layer and a semantic backbone. But a semantic layer is the first step. So you have to make the meaning of the data per silo in a way explicit and understandable to your RAG workflows, to your agents, whatsoever. And they cannot be done per silo, obviously. So you need to have a unified semantic layer on top of all the silos. and it's well forgotten, if you look at your Databricks, Snowflake, SharePoint, whatever, you won't find domain knowledge there necessarily. A bit probably, but the reality, it's still in our heads. It's up here. It's nowhere written. Yeah? You go to several domains, insurance, banking industry, pharmaceutical. If you look at the data, if you're not heavily involved in the business context, so there's a lot of context missing in the databases that you are able to interpret the data. And that's why those systems, and we see it all over the places, huge installations, tens of thousands of seats, try to get involved in AI projects, and the agents just don't understand the data you've stored in your Dynamics, in your Salesforce, in your wherever. The agents don't understand it because the context is missing. They don't understand the business context, the tribal knowledge, the tacit knowledge. It's nowhere in the database. So you have to inject, and this is super important, this explicit knowledge, this domain knowledge in form of ontologies and taxonomies. And when I say ontology, it's not just a schema. Yeah, schema mapping is only the first step. That's not good enough. It's not providing any additional value. So obviously we are not alone. That's good. It's Microsoft talk about semantics, Palantir using ontologies. I mean, you always have to look at the point, what exactly is their ontology? Will you own it, or will it be owned by the hyperscaler? That's also an important point, yeah? Snowflake, Databricks, they've built this semantic initiative, Open Semantic Alliance, I think it's called. It's a great step forward. They've seen we need semantics on top of our data. Otherwise, it will never be used by AI at scale. And Gartner is very explicit since years, by the way. And just in May, at the Data and Analytics Summit, also here in London, this quote comes from there. It's really about AI governance vulnerabilities. It's about costs exploding. It's no longer negotiable. You need to do something in this field. That's good. So now I would really like to give you a bit of a specific idea why it's so important. Because many people say, well, we have already a lot of metadata. What's the problem? Okay, let's take a closer look. This is a very small example. If your agent or whatever wants to have information about, in that little case, about vitamins, then it gets broken quickly because all the databases probably talk about vitamins, but it's not well understood. Maybe it understands it's vitamin, and the ergocalciferol is, I think, vitamin D, if I'm not mistaken, and the other one is vitamin K2 or whatever, yeah? But what kind of vitamin is it? Is it important for my particular case, for my symptoms, yeah? All that kind of knowledge is nowhere written. You won't find it in an enterprise data landscape, except you inject that knowledge as a specific asset, right? So in other words, all the silos are well maintained in terms of they will have a lot of metadata to stay compliant, most of all, and to have some system metadata just to make sure the data is well perceived. But it's not knowledge what's put on top. And in sharp contrast to that, and there are little now icons there, now ergocalciferol and vitamin becomes an asset in this environment. So it receives a uniform resource identifier. It's a thing in your landscape from now on, yeah? So it's no longer inside the box, it's an asset on its own. It's addressable by any agent in the landscape, by any other application. So, and the relationship between all that is also clearly defined now. So it says things like in an ontology, like has positive impact on, etc., etc. So this kind of structure between the information an agent needs or the application wants to have and the data itself, this semantic layer is now in place. And that's done via ontologies, typically based on the Resource Description Framework Open Standard Stack, RDF, right? Okay, so all that, by the way, has been adopted by the pharmaceutical industry since decades. They are totally at the forefront. They call it fair data. It is based on 4 principles, like findable, accessible, interoperable, and reusable. Those guys have been adopting semantic layers using the RDF stack since decades. One of the largest customers we have is Roche, yeah? Obviously the biggest one in the field, using that stack since years. They use a semantic backbone based on Graphwise, by the way, and they can, by that, use their knowledge across all the silos they have in a completely different way. It's connected, it's interpretable, the agents can use it, and it's really interesting that pharma was at the forefront. My hypothesis is, I mean, as a human, you're a network, you're a graph. So you're interconnected, your cells, your proteins, your genes. So they already understood very early that the whole world is a graph. Yeah? It's not a table, it's not an Excel sheet, and it's not a relational database. I'm a graph. Yeah, and also how the interaction of proteins, etc., can be interpreted as a graph. So that's why I believe this industry has been always on the forefront. Okay. You've heard about context layer a lot, I'm sure. So this is an interesting new term. What is it? What is the knowledge graph? What is the context graph? It's super important to understand how they play together. It's not an either-or decision. It's just different perspectives on what's going on in an enterprise. You could easily say the knowledge graph is like the static knowledge. Yeah, okay, how does my product get sold on a particular market, what compliance rules are in place, etc. That's the knowledge graph. And then the context layer typically is more the procedural knowledge. So the dynamics behind that, how things evolve over time. And they should be fused, they should be connected with each other. So it's not good enough to have the one or the other in the long run. But you have to start with the knowledge graph. You cannot just go ahead and say, I skipped that part and I build a context layer. Of course you can do it, but you will still fail to produce AI, multi-agentic systems which will deliver on the promises. So that's the stepwise approach. And the semantic backbone, now finally the kind of definition is the fusion of the knowledge graph consisting of ontologies and what I've just shown you before, and the context graph will result in the semantic backbone powering the multi-agentic systems. And you could also now break it down into smaller chunks of activities. Like if somebody asks me how to start, I would say depends, of course, on your business and the data you have, but a good way is to start with costs. It's regularly seen. We have very large customers who have done exactly this, starting from taxonomies using this cost standard, adding more and more ontologies, creating enterprise linked data, the knowledge graph, and then adding a graph rag on top, also to produce return on investment quickly. That's also important. You cannot boil the ocean for years, and then only then you have some good stuff in place. So you should also have a way to roll out graph rag systems relatively quickly, and then you can keep on going, adding more and more parts of the context graph. And I think we are not in the middle already of everyone rolls out multi-agentic systems which do really complex stuff. It's rather the simple stuff. Yeah, you have multi-agentic systems, but the complex stuff, I have not seen many customers or enterprises yet which do really complex stuff with autonomous multi-agentic systems. I don't know. Have you? Let's be brutally honest. Who has seen that? No, nobody. Okay. That's our platform. Is exactly doing what I just showed you more or less on a methodological level. So you can ingest data from all kinds of databases, structured, unstructured data, also virtualized. That's the graph automation piece. We have our very own graph database, highly scalable, GraphDB. Maybe some of you know that one. We have our graph rag system, front end, back end, also show you a little screenshot then afterwards. And by that, this starts to get fused, those two worlds, like the knowledge graph, the context graph, and then on top of that, the agentic orchestration. And again, it's super important. Retrieval is still important. If you do retrieval very well, then obviously the rest will work very well. And in complex domains like, let's say, chip machinery manufacturing, you should stay really precise with the description of what's going on there. And therefore, you need things like graph rag and knowledge models and precise metadata. And so that's where we believe a semantic backbone is really needed. I'm not saying it's everywhere needed. There are industries which are highly standardized, let's say McDonald's, yeah. While we also have in that industry a couple of customers when it is about ramping up new people and skill them up, stay compliant with health-related regulations, it's also complex. So, okay, that's a quick screenshot also how our graph rag low-code workflow engine looks like. So obviously you still have to stitch together several steps in done typically by data and knowledge engineers, but a big difference in that architecture to other RAG systems is you have a clear split between the knowledge engineering part, so where you really build the domain knowledge, and the way it's then used during the execution phase. So you can split the work between data engineers and knowledge engineers, but still let them work together, and visual interfaces are needed also to create the knowledge domain models. That's super important. You cannot code them in a notebook. You want to let the subject matter experts be part of that. So one great example here is another bank in Australia. It was the subject matter expert was really puzzled that again the RAG systems didn't produce the right answers. How can I influence that? You go into the system, you create additional context about a business object which was involved in this response, the wrong response. That was done really in a very simple way by the SME. Press the button, save that, rerun the pipeline, and voila, now the agent produced the right result. So we need ways to let the SMEs be part of the governance model, really. And for me, it's not about accuracy only. So to be accurate with results, I think this is going to be resolved relatively quickly. LLMs get better and better, but still, they will never reach 100%. You need ways to get to 100% accurate questions, answers and responses, and that can only be done when you have the human in the loop. It cannot be fully automated. And that's another example. Like, we see that very often. Customers say, we have tons of knowledge in our knowledge bases. Is it SharePoint or Dynamics or whatever product database? And we reinvent the wheel again and again. And we want to know in a far better way where have we done something similar already in the past. And that's not trivial. So you see here, this graph represents people, project, and their skills. Of course, it's a small example. In the real world, it's huge. And then you want to know where can we reuse parts maybe from an offering we did in the past already, which would fit into the new requirements, and who are the right people to work with. And that's really a multi-hop reasoning you need, because you have to hop over several nodes in the graph. And now with a, let's say, classical RAG approach, it will produce to 90% or so good results, but it loses at some point the meaning of the query. So it cannot really interpret it, the question in a deterministic way. While, for instance, solutions like talk-to-power system, as we've produced for several TSOs, grid operators in Europe, you need 100% accurate answer. So in that case, the multi-hop reasoning or the graph traversal is not done in a probabilistic manner, but really goes down to the database and executes a Sparkle query. So the query can be very complex queries, like which transmission element, is interpreted from natural language query into a Sparkle query, and then looks up in several steps to find the right information in the graph database, and then you have 100% accurate answer. It's 100%. You can trace it back even. You can look up where does the data come from. You cannot do that always, like Biograph talk is also quite deterministic. If you talk Knowledge Hub, we still have a lot of unstructured data. We're not claiming that you can always produce 100% correct answers. It's not possible. But with other domains, it is. So our mantra is use, of course, whenever possible, the best version, which is NLQ to SparkQL. If not, then there's a lot of semi-structured data. We use that, XML schemas, transform it into graph formats, and then enrich it with background knowledge. So we do our best for our customers to reach that level of accuracy, but in all the cases, it's the SMEs who are really involved. So it's no longer opaque pipelines. We address hallucinations. We can include even those guys who have absolutely no knowledge about RAG or ontologies or whatsoever. They just have an eye on, is this compliant or not? So we can help them really to influence the output. And most of all, it's about siloed knowledge. So the first step always is to link the data across the different silos in a consistent manner. And this is actually the architecture here, which also shows quite nicely. All the semantic layers on top of the different databases are a great first step. They do a lot of schema mapping. They make a consistency about metrics. It's typically BI-oriented. And all that feeds into the enterprise semantic backbone. But what you need is domain knowledge and also a mapping between different subdomains and the procedural knowledge to add the context layer. Only then that will ever work.